Hello everyone, my name is Rajafari and I would like to welcome you to another video. This is going to be our third video in our deep learning series, and in this video we are going to focus on the sort of process of getting a neural network working using Keras from Tensorflow, right? So that's our goal going to be. We're going to start with how what we do would have looked like if we were to use other neural network from other modules, and then it would kind of look like look at what would that look like if we were to use TensorFlow and Keras. And with doing that, we're going to sort of like also talk about sort of this trade-off, when and where is it better for us to start using TensorFlow and Keras instead of what perhaps we we were used to doing. All right, so that's going to be what we will be talking in this video. All right, let's get started. Okay, so as I said, this is going to be the third video, deep learning prediction via Keras and TensorFlow. First, we're going to sort of like go through some of the stuff that I had already done in previous videos, right? So these are all that stuff, right? So these are the required packages, and let's look at an image together to sort of like have a problem understanding. So this is the data set that we are going to be using, right? And on this data set, it has 8 independent attributes and 1 dependent attribute price. So each row is a car, is a vehicle. It's a Toyota Camry vehicle, and we want to basically be able to predict the price of the vehicle based on these attributes, right? So that's what we're going to do. As I'm pretty sure you know, if you're watching this video, for us to be able to do that, the best way is to sort of set ourselves up for success, and that means make sure that the model we're creating is not just a fluke, and we use the industry-wide standard process of using the test set, right? So we split our data into training set and test set, and by making a model using the train set and then making sure that our model is of any good using the test set, right? So that's basically what we are trying to do here. At the end of this video, you're going to be able to get this done using Keras and TensorFlow, right? So a few things to do before continuing is sort of making sure you know the basics. If you want to get to know more about this data set, you can watch this video of mine from before. Or if you want to sort of like look at the prediction of car prices for the same data set using linear regression, you want to watch this one, right? So these are the things that I'm just going to like briefly go over them here in this video. But if you want a more in depth, you want to look at these videos, right? Also, if you don't know what's the prediction in data mining realm, you might want to check out these 2 videos. That's going to be very helpful, right? So this code here, this is all coming from this video, right? So let's just get this run and let's talk about its output, right? So when we run this code, basically 3 predictors are run and compared to one another, right? So the first predictor is a random predictor, right? So it's a random predictor and randomly predict a number between the minimum and maximum. And here we can sort of like visually see how good it did by showing the absolute value of the difference between the prediction and the value, right? Of course, when we do it randomly, it's not going to be good. However, we do it to give ourselves some sort of baseline to sort of understand how good the model we are doing is doing. Right? Is it doing better than random or not? The second method here is also another naive method, which is basically predicting every one of the cars as the mean of the population, right? So this is a naive mean predictor. And of course, we can see it's doing better than random. Again, this is another baseline that we are using, right? So these two baselines are our baseline as far as like how bad or how good it could look like, right? Just visually. And this one is linear regression. And we can certainly see visually that linear regression significantly is doing better than just using the mean, right? So this is a visual way of going about how well our prediction, how our model is doing, right? So we can also, instead of doing visually, look at some metrics such as ME, RMSE, MAE, and MAPE. If you want to know about this, please go ahead and Google them. These are important to know if you want to know the difference between them. However, just for the sake of it, I would bring to your attention, MAPE is the one that is percentage-wise, right? So the number of data objects that you have in your sample when you calculate it, pretty much sort of like does not influence the magnitude of this value. So it's sort of between 0 to 100. Sometimes you may see worse than 100. Those are really bad predictors, but the magnitude is roughly around 0 to 100, right? So when this is between 9, you can sort of think of this as 9% error, right? So this is linear regression. Another video that you might want to watch before continuing on is we have done the same prediction using artificial neural network with MLP with the ML regressor from the I think scikit module, from an SK layer module, right? So we have also done that as well. You can watch that video also if you wish to. And if you don't know what is MLP or artificial neural network, this video will give you a pretty good idea of what it is and give you a good understanding of why we think that it works, right? So these are two other videos, right? So this is the code from this video. We basically, we say this is my test, this is my train data, and this is my test. Let me see how good you are doing, right? So this is a very sort of like non-tuned, very raw format of this model. We are using random state, and the reason that we're using random state is that if you are following along with this code, if you run this code without random state, every time you run it, it would give you a different answer, right? However, when you run with the random state, wherever you are, and every time you run it for yourself, we are going to get the same result. So that's why we've got that random state. So we can also look at the results, and we can see MLP is doing worse than linear regression if without tuning, right? But slightly better than our baseline, right? So it's not as bad as our naive mean or the random, but still not as good as our linear regression. So if you want to look at what is random state, this is the video you want to watch out. So this is another video. If you want to know more about what this random state is, that's the video you want to watch out, right? All right, so that's that. And now we want to talk a little bit about tuning MLP, right? So in that video, we talked about this as well, about tuning MLP. So basically, there are a lot of hyperparameters that MLP has, and we want to take our time with tuning it. And when we do tune it, right, using normally a tune set or a validation set, right? So the validation set should not be mistaken for test set, right? Validation set or tune set is the part of the train set that we keep reserved to tune our algorithm, right? So using that validation set, when we do all those tuning, right? So this is, how those would look like. So our, big train set had 1000 on 1000 data, but then when we separate the train and the tune, now we would train on 804 and we tune on 201 of the rows, right? So using these, then we tune it, and then we come to these hyperparameters. So this is, I'm not tuning it here. If you want to see how we went about tuning it, please watch that video. However, these are those hyperparameters after tuning. Sure enough, when we tune the algorithm, it does much better than non-tuned one, right? And it can also show us that it's doing much better than the MLP. However, it's still not beating the linear regression. So, so far with what we are looking at, linear regression, such a simple method, is doing better than MLP even after tuning, right? So that's where we are. So now, for the rest of this video, we want to see how we would have done what we did with MLP here, basically, right? So this is, what we did with MLP, right? We want to see how we would go about doing this if we were going to use Keras and Tensorflow, right? So that's basically the goal of this video. So let's do that. This is the new material, right? So this is the new material. Why are we doing this? If we have an MLP that is working, why are we learning something new, right? So MLP from sklearn module is great. It's managed at a very high level. So you just need to choose the hyperparameters, and this is my train data, this is my test data, whatever, and just get the result and you're on your way. However, with Tensor and Keras, you actually have to do more to get things started. You have to put more line of codes and more specification. And the tuning process also may be a little bit more hands-on, meaning that you have to participate in the tuning process. However, because you've got more control and it has very many good APIs, by sort of opening this up and going a little bit lower level, you're not going all the way down to the CPU level. You're going a little bit lower level than the sklearn, but it opens up a lot of possibility for us to use deep learning in many different and useful ways, right? So in this video, we're not going to get to see those, right? So please stick with me if you want to know about. So now we went to a little bit lower level. Now, so what? So you show me some examples of that. Those are going to come in my future videos. But in this video, we're going to see how we would have done this, the same thing that we did with MLP in my other videos, if we were to do it with Keras and Tensorflow, right? So that's basically the goal of this video. So here, of course, we import our Keras from Tensorflow and the layers, right, from Keras. And this is how we would introduce the same model that we had, similar model that we have, with 8 neurons in the first, in the only layer. And then this is going to be what we have as our output, right? So we won't have to introduce the input. It sort of is done automatically once the network starts fitting. But with the output, we have to specify that. This dense one layer is our output. Also, we have to specify our activation per layer, and also specify our optimizer and our loss function. All of these, we kind of specified them when we showed our MLP as well. These are what we tuned, right, with our MLP. I went too far. These are the stuff that we tuned with our MLP, right? And actually we are here, right? So kind of the same, kind of similar stuff going on here. For instance, the solver is here, the activation is here, right? However, here, for instance, you can have various activation per layer, but with SQL layer, you can just have one activation. There are a lot of advantages of using Keras over SQL layer. However, let's just give this a try, right? So we set this up, we set our model, right? And then we compile it, right? And once we run, right? So it's sort of like import the stuff and set the model up. And once the model is ready, exactly like MLP, we say this is my train data. This is the number of epochs, the same as MLP that we had, 2000. And my batch size is how often I want to update my weights or the weights on the connections. And with MLP that we did, it's the batch size automatic, and it's just as many rows you've got in your train set. So because of that, I am setting that as the same thing, and Keras gives you a lot of output once you run it. But for the first time, I just want to let it run and see some output. So I have put the verbose as 0, which means don't give me an output now. I don't need them. So now we've got this, right? So our model is fit exactly like any other SQL layer module. We can just say, okay, predict the the test data, and let's look at how the prediction went, right? We can see that it's not doing as good as linear regression or tune MLP, the MLP with Keras, but however, the data objects that the MLP, non-tuned MLP were challenged with, the non-tuned MLP from Keras were also challenged with. So there is some similarity there. We can also look at the metrics, and we can see that it is performing similar to the MLP, non-tuned MLP, however it's actually performing worse. And towards the end of the video, I will share with you why that is. Again, it's all about that sort of like compromise and pros and cons that you have to understand before choosing your tool if you want to use SQL layer or Keras. So let's start looking at some of the advantages of Keras, right? One of the advantages is that we can take advantage of the history. It gives us history, a very nicely logged log of all the epochs of training, all of the metrics that we want, right? So we also add our validation to start also our tuning process, right? So before we train on X train and Y train, but now we are training on that smaller part of X train, which is basically the train minus the validation or tune set, and we specify our validation data, right? So you can see doing the validation is much simpler with Keras. You can just like say, okay, this is my validation data, use this to give me some report, right? This time I am not putting the verbose equal to 0, so you want to like sort of take a look at the kinds of output that Keras gives us, right? So per epoch, it gives us the output. It tells us the time it took, what is the value of our loss function at the end of that epoch, what is the metrics. So we get to also choose some metrics. So because maybe it's that metric that is insensitive to the number of data objects, I have chosen that. And then also it tells us the value of the loss function, and also the value, the loss function for the validation set and the loss function for the MAPE, right? If we scroll down, right, so keep your eyes on the loss function for a minute here. You can see the loss function keeps decreasing, right? So this is the gradient descent at work. It's working, optimizing on the loss function, and as that decreases, also our MAPE value decreases, right? It just keeps decreasing until it gets to 15%, right? So this is what we all had already seen, but now we can sort of see those values. But also for the loss validation of loss function and the map of the validation, we also have it. We can actually do much better than just looking at these outputs, right? We can say, okay, whatever you are outputting, let me grab that from the fitting function, and that's the history. Basically, this is history log. We can take advantage of the history log to plot the loss function, the loss function for the validation, and the map and the map for validation, right? So we can draw them, and now we can also see what's going on with them. We can see that there was a major decrease in the beginning, but then the slope we are decreasing with a bit slower rate. However, we are still decreasing, right? So we haven't been able to overfit based on the model that we have. So that's one thing that we want to pay attention to. So one thing that would be a good idea is, instead of having this code here, let's just create a function that we can just call to give us these visuals, right, for the purpose of the future training. So we create that function, right, and we also include a sliding window that basically, if we wanted, we can take a look at any parts, let's say from 500 to 750, or from 1,000 to 100 to 1,000 to 250, or whatever we want. So if we can focus on one part of this visual if we wanted to. So this is included in this visual, in this function, right, by including these. So we can sort of use it if we want to. So if you don't want to use it, you just don't say anything. But if you wanted to use it, let's say I want to focus on see what's going on here, let's say from 250 to 500, right? So I pass this value as 250 to 500, and now I get to see what's going on there, right? So I can see actually what's going on in those values, right? So let's go back to what we had. We're going to use this in a minute. Alright, so another advantage and great thing about Keras is that you can use the batch size with any optimizer. With sklearn, only a few of the optimizers you could use the batch size, but here you can use the batch size. And so let's just go ahead and use the batch size. And one of the good things about using batch size is that you get to sort of improve your network faster because you get to update it more often, right? For every 201 exposure of your values of your data objects, you update your network one time, and that is going to have an impact. It's going to have a quicker impact on your learning process, right? So the only thing that's been added here is just the batch size, right? Everything else is the same. And as we get this to run, we can actually see, because we've got smaller batch size, right? So then the number 201 comes from the division of 804, which is the train set that we are using here, divided by 4, right? It doesn't have to be, but it would be a better idea to have it sort of as complete all of the batches as the same, or roughly the same number of data objects. As we scroll down, we can see that this is a much faster training process, right? Meaning it's way faster. I don't mean that each epoch runs faster, but I mean is that we need less epochs to get to more learning, enough learning for us to get to a good network, a good trained network that has the potential to predict what we needed to predict, right? So we get there, and again, we can just go ahead and create our history. Now we can see what's going on here. So there is some interesting things going on here. and some stuff going on here as well. We can see that at some point we didn't really improve that much our loss function. Our improvement like really plateaued, and here we can see on our MAPE at some point we started not really improving with the improvement of our MAPE for the training set, right? So for instance, we can check between let's say between 250 to 750 to see what's going on with those areas, right? So this is our sliding window, and we can see that from here the gap got a little bit wider, and then we are not really like improving that much. Kind of the same thing here. This actually we want it to be 200. Yeah, exactly. And here the same thing. Same thing, we are not improving that much. Here we are doing a little bit better, and around this value, right, around here. So this is that. So maybe that's the best network, this plain network that we would have wanted to do. However, pay attention here that we're only using a small network, right? With batch sizes, now we've got the advantage because we've got more updates. It affords us to use larger networks, right? So I'm making the networks much larger here. It used to be only 8 neurons. Now I've got 3 layers. The first 2 layers are 16 neurons, and the third layer is 8 neurons, right? So it's a much larger network. And let's see how, if we change the size of the network, that will change anything, right? So again, this has to run. Another thing that I have changed here, I'm using one of the Keras's callbacks, right? So these are called callbacks. In one of the future videos, we'll go over all these callbacks, but this specific one basically is used for us to save the best model based on what we want. Here I'm saying monitor the value, the MAPE for validation set, and when it gets to a minimum, save that one, and it would be the model that it would be used when you say model.predict. That's basically that is. So we add this as a callback here, right? So we add this as a callback, and we can see that it reached pretty much where we had reached before. It's kind of like have similar performances. The performance have more ups and downs, right? Just because we've got larger network. We can also zoom in wherever we want. For instance, here we can zoom in from 100 to 200, see what's going on here, and we see that it's pretty much sort of the same, but there are some of them that the validation is doing better, but it's roughly the same. It's been decreasing, right? So we can see what's the minimum value for MAPE. It's around 14.9. I think it would be around here or here that we get there, right? So let's go ahead and use that best model based on the minimum value of MAPE for the validation MAPE and see how that would look like. And we can see that it's certainly doing better than the non-tuned Keras MLP. However, it's not doing as good as the tuned MLP with Keras, or even it's not doing as good as the MLP without tuning or the linear regression. So we managed to sort of like achieve what we wanted, which was to sort of like see how it would look like if we were to use Keras and TensorFlow to do our prediction. However, we were not able to manage to actually get a better prediction, right? For that, we need much more knowledge and understanding of how neural networks and deep learning work. And the reason that we were able to do that, reach at least close to linear regression with MLP tune, is that sklearn MLP comes highly managed at high level, right? So you've got a lot of regularization strategies to combat those overfitting possibilities already baked in, right? So those already in place, and you don't need to worry about them. However, we did not use any of those strategies yet. There are some strategies that we will learn as we start about this process, and that's going to be actually one of the videos. We're just going to talk about those strategies, and because we just need to know more. However, like I said, we managed to achieve what we wanted, to see how it would look like if we were wanted to do similar thing what we did with sklearn, with MLP, regressive XLA, if we wanted to do it with Keras. So we managed that. So before finishing this video, let's talk about the big picture where we are in this course. So we've already covered 2 videos. The first 2 videos were conceptual foundation of deep learning, and this video is actually getting our hands dirty with Keras and Tensor. These are the tools that we're going to be using in this course. Now in the next video, we're going to use these 3 videos to make some progress on these topics, right? So in the near future, you should expect to see more videos on these topics, as I said, and by going through these, making sure that you've got a good understanding of them, then you're going to be ready to talk about this. On one of the videos, we're going to talk about loss function and how we select it. For us to understand that, we need to understand gradient descent, and what is the model, what is the solver, what's the activation, why is it, but does it matter? The fact that we actually want to first overfit our model and then go from there. We'll talk about all of that in this video, and then we start putting everything together to come up with one thought process as you would approach any problem using deep learning. And after that, we look at the more high-level ways that we could use deep learning. And for us to be using these high levels, like I said, we have to go at a tool that is not managed at high level. It gives us more things that we have to manage and we have to decide about. However, it allows us to combine these different types of networks, bring in different things, and do more experimentation. And that's why we are choosing to challenge ourselves to learn about Keras and TensorFlow, which are, like I said, are at lower level than something like sklearn, MLP regressive. Alright, until next video.